The learning objectives for this video are to be able to solve inequalities and graph their solutions. So first, describe the following inequalities in words, and then graph them on a number line. Pause the video and try that out. Okay, so the first one would be x is greater than -4, which means x would be all the values that are greater than -4. That would be this value and all of these values all the way back until you get to -4. And then when you get to -4, all the values that are above -4 count, but -4 would not satisfy this inequality. So what we do at -4 is we put an open hole like that to demonstrate that -4 is not included in our solution set. For the second one, it would be x is less than or equal to 3. So that means x is going to be less than 3. It's going to be all these values all the way up until you get to 3. And then at 3, it would include 3, so I'd put a closed hole to demonstrate that I'm including 3 in my solution. Question 3 is interesting. X does not equal -2. That means that x can be all of these values and all of these values, but it can't be -2. So I'd put an open hole at -2 to demonstrate that it can be all values that are not -2. Okay, so those are called simple or single inequalities. The following are called compound inequalities. Describe the following inequalities in words and graph them on a number line. Pause the video and try it out. All right, so I wrote these out in words. For instance, x is greater than 2 and less than or equal to 7. We also have or statements. X is greater than or equal to 5 or less than -1. And then we have these ones that don't have the word and or the word or. These ones are implied that it is and. So this is an and statement and this is an and statement. And let's see what happens when we graph them. Number 1, x is greater than 2. So here's 2, and I'm going to put an open hole at 2. And that would be all the values that are greater than 2. And then also x is less than or equal to 7. So at 7, I would put an open hole, and it'd be all the values that are less than 7. And then the values where they're both happening is the overlap. And that's going to be all the points that are both greater than 2 and less than or equal to 7. And that'll be this area. Oh, sorry, this is supposed to be a closed hole. Closed hole there. So that would be all the values from this closed hole extending down to this open hole, which would leave us with an inequality that looks like that. It is an open hole at 2 and extending up, the overlap of those two. When it's or, though, it's not the overlap, it's both of them. Here, x can be greater than or equal to 5, so here's 5, and I'm going to go greater than or equal to, and it's going to go this way. Or it could be x is less than -1. So here's -1. I'm going to put an open hole, and it can be either. With or cases, or inequalities, you get both regions. With and inequalities, you get the overlap. Question 3 is an and inequality, which means we would have an open hole or a closed hole at -2, closed hole, an open hole at 3, and then the union of those two, the interval between. Question 4 is interesting. Question 4 says that x is greater than 5 and less than or equal to 1. Well, let's think about that. X is greater than 5, so here's 5, open hole, greater than 5. Or less than or equal to 1, here's 1. It's going to be a closed hole, it's going to go that way. And it's an and statement, which means it's the overlap of those two regions. And in this case, there is no overlap, so there is no region. No region. Kind of like a no solution. Question 5 is also interesting. X is greater than 0. So we're going to have an open hole at 0. And it's going to be greater than 0. Or it's less than or equal to 7. Here's 7. Or it's less than or equal to 7. And or statements aren't an overlap. It's all of the values. In this case, all numbers are either greater than 0 or less than or equal to 7. So we actually get the entire number line. So that is graphing compound inequalities. And statements are the overlap. or statements, or the union it's called, which is both regions put together. Sometimes you get no regions, and sometimes you get the entire number line. Now we're going to start solving equations. We're going to start solving inequalities. Solving inequalities works almost identical to solving equations. We're going to follow inverse operations to isolate the variable. So here we would subtract 2. 3x is less than 9. Divide by 3, divide by 3. X is less than 3. Now there are lots of places, lots of values that would satisfy this. It would be all the values where x is less than 3. So now we can graph our solution. Here's 3. I'm going to put an open hole at 3, and I'm going to go less than 3. And here are all of the solutions. And if you check one of these solutions, let's say we check -5. If we put -5 into our inequality, we can see that indeed it will satisfy our inequality, just like values can satisfy equations. All of these points satisfy our inequality. But there is one major difference that you'll see in Algebra 1 between solving equations and solving inequalities. And here's the big difference. Whenever you multiply or divide by a negative number, -2x equals 12, when I multiply or divide by a negative number, the inequality sign flips. And that's the big difference between these two. When you multiply or divide by a negative, the inequality flips. There's other special cases with inequalities that you might see in future classes, but in this class, the only special consideration is flipping the inequality when multiplying or dividing by a negative. This then gives us the inequality x is greater than -6, so here's -6, an open hole there, and we're greater than -6. And we can check some of these values. We can check 0 very easily. 0 is a good number to work with because it's so easy. Did it satisfy our inequality? Is 1 less than 13? Check. It did. So it works. This is a compound inequality. We can also solve these. This is an AND statement. This is an AND statement. So what I can do is there's a few different ways to do this, but kind of the easiest way to see it for the first time is what I'm going to do is I'm going to treat this as two different inequalities. And I'm going to solve both of those inequalities by subtracting 5. I get -18 is less than or equal to -3x divided by -3 divided by -3. And the sign flips. It was like this. Now it's like that. Sticks. And this one, do a little bit of work, and you wind up with x is greater than -3. And this is an AND statement. AND statement. So it's x is less than or equal to -6. Here's 6, or +6. Closed hole, going down. And x is greater than -3. Open hole, going up. And it's the union of those two. So there's my solution for a compound inequality. Try this one. Pause the video and solve it. Remember that if you multiply or divide by a negative number, the inequality sign flips. Okay, so I solved my two separate inequalities because it's an AND statement, and I wound up with a sign flipping when I multiplied both sides by -2 with x is less than -7. So here's x is less than -7, open hole, going this way, and x is greater than or equal to 1, closed hole, going this way, and it's an AND statement. So this would be the overlap of the two. There is no overlap here, so this one has no region and no solution. And that's solving inequalities, including compound inequalities with no solution. If you have time, here are 10 questions you can try. Pause the video. Try these out. They start out with single inequalities, then they go to compound inequalities, and I'll put up the answers in a second. And here are our answers. Check your answers. Notice number 6 was a no solution. And you should be able to tell how you're doing at this point. We'll practice this tomorrow in class and come to class prepared.